Good evening all. Welcome to YouTube live session. So regarding introduction, this is from ThinkCell and group of institutions, which is also GATEFORUM. So everyone awareness about GATE, that is 100 marks and 65 questions. Out of these, 15 marks on engineering mathematics, that is minimum. Worst case, that is rare cases, 13, 12 marks. Maximum times 14, 15 marks. Similarly, rare cases, depending on the stream, mechanical or civil or electrical or electronics, communication, computer science, information technology, etc. Chemical engineering, biotechnology, etc. So 17 marks, 18 marks also. On an average, 14 to 15 marks guarantee. Next, you have another subject, that is NAVA, that is numerical aptitude and verbal. So that is also 15 marks, either 8 plus 7 or 7 plus 8. So this numerical aptitude is also nothing but a mathematics topic, which is from 6th, 7th, 8th class, 9th class, 10th class. That is our childhood classes. That is ratio, proportion, simple interest, compound interest, and both upstreams, downstreams, permutations, counting techniques, geometry, data handling, etc. There are the 10, 12 subtopics, which includes 8 marks. So finally, this 15 marks engineering mathematics and then numerical aptitude, that is mathematics also 8 marks, altogether 23 marks, and verbal aptitude, that is English, 7 marks. Altogether, this is 30 marks. That is almost 1/3 of your GATE total 100 marks. So the remaining technical subjects, depending on your stream, either 8 or 9 or 10. So altogether, the technical subjects together marks is 70 marks. Okay. So in all this, compulsory engineering mathematics and aptitude subject, because it is good scoring while solving these mathematics problems, either your childhood classes or engineering, so that you will understand in a better way and your mind approaches very fast, sharpness increases based on your technical subjects. Moreover, your technical subjects, out of 10 questions, 8 questions compulsory problematic approach only. That is application oriented only. Okay. So in all the remaining 8, 9 technical subjects, it is sufficient 6 subjects, maximum score, 5 to 6. Maximum score means just like engineering mathematics, 12 marks, 15 marks. That is, you have to select based on the previous 8 to 10 year questions, select properly. So out of your 8, 9 technical subjects, 5 to 6 sufficient is 5 to 6 subjects is sufficient. So that altogether your marks maximum you score 75 to 80 marks. Definitely you will crack. That is, you will get seat in IITs and good jobs also. That is public sector jobs. Okay. Similarly, in softwares, or some softwares also they need the GATE rank also. Okay. Now, my experience is total teaching experience is 20 years. Since last 10 years, so I worked with GATEFORUM, that is ThinkCell group of institutions, and so now I am giving a lecture on the subtopic rank and system of linear equations, which is purely related to matrices, which is nothing but linear algebra chapter. Okay, so the first one, based on rank of a matrix, there is a method, row echelon form. Echelon is a scientist. Okay, so row means you know that horizontal lines in a matrix. Column means vertical lines. Okay, so now I'm explaining a matrix A m cross n. So m cross n means it is order or size or dimension of the matrix. The first suffix indicate row, second suffix indicate column. So either square matrix or rectangular matrix. When number of rows equal to number of columns, such a matrix is square matrix. When number of rows not equal to number of columns, such a matrix is called rectangular matrix. Any matrix is said to be row echelon form if 2 conditions satisfied. But first condition is optional in some examples. So 0 rows if any. That's why I wrote in the brackets if any. What is 0 row? In a matrix, a row containing all the elements zeros. Such a row is called zero row. Otherwise, it is called non-zero row. For example, in this example, see, the last row, all elements zeros. This is zero row. If any, they must belong to last of the matrix, that is bottom of the matrix. Suppose if any zero row in the beginning or middle, you have to take into the last position of the matrix, that is the bottom of the matrix, just by applying interchanging of two rows operations. R1 interchanges R3, R2 interchanges R3, like that. Next, second condition. Number of zeros before the first non-zero element in each row. For example, in every row, if there is a non-zero element, say it is first or not. That is, your identification is in every row, first non-zero element. Before means left side, after means right side. So for every non-zero first element, find the number of zeros left side to it. That is, before the first non-zero elements, count the number of zeros. That zeros should be increases from first row to second row to third row. Strictly speaking, that row echelon form means elements below the diagonal zero. That is upper triangular form. You know the meaning of upper triangular matrix, a square matrix in which all the elements below the diagonal zero. Such a matrix is called upper triangular form or upper triangular matrix. Okay, so number of zeros before the first non-zero element in every row is less than such type of zeros in the next rows. What is the next rows? If you are checking the condition in the first row, what are the next rows? Second row, third row, etc. So now let me explain this second condition in one example. So here I took 3 by 3 matrix. 0, 1, 2 first row elements, 0, 0, minus 3 second row elements, 0, 0, 0 third row elements. Now, so just I will highlight by red color. This is the first non-zero element in the first row. Before it, how many zeros? 1 0. In the second row, this is the first non-zero element minus 3. Before it, left side, 2 zeros. So here 1 0, here 2 zeros. That is, zeros increases from first row to second row or not? Now, in the third row, there is no non-zero element. All are zeros. So this zero row is the bottom of the matrix. So such a matrix is called row echelon form. That means if you see these three are the diagonal elements, 0, 0. Elements below this diagonal zeros, that is called upper triangular form. The new method, new name is called row echelon form. To understand very easily, better to remember upper triangular form. So now what is the advantage of this row echelon form? To find the rank of a matrix. So underline rank of matrix A. The number of non-zero rows is called rank of matrix A, provided that matrix A is row echelon form. So rank of matrix A is nothing but number of non-zero rows. So usually rank of matrix A is denoted by row A. This is the symbol stands for rank, Greek letter. Some people simply R of A or rank of A. So in the second example, the first -1 is the first row, first non-zero element. Before this, no zeros, that is 0 zeros. In the second row, 1 is the first non-zero element. Before this, 1 0. In the first row, 0 zeros, that is no zeros. In the second row, 1 0. So it is increased by 1 0 or not? Now, in the third row, this is the first non-zero element. Before this, 2 zeros. So no zeros in the first row. And in the second row, 1 0 before red circle element. And in the third row, 2 zeros before the red circle element. Each red circle element is the first non-zero element in each row. So that's why these three, if you consider diagonal, but we should not speak diagonal elements in a rectangular matrix. Okay, in a better understanding, I am telling like this. So 3 cross 4. So elements below these 3 circles, zeros. This is called upper triangular form. So hence the given matrix is row echelon form. How many non-zero rows? 1, 2, 3. What is the meaning of non-zero row? A row in which at least one element is not equal to 0. Such a row is called non-zero row. What is zero row? A row in which all the elements are 0. Such a row is called zero row. So here 2 non-zero rows, here 3 non-zero rows. According to advantage of row echelon form, rank of a matrix is defined as number of non-zero rows. So in this 2 non-zero rows, in this 3 non-zero rows, hence for the first example, row of A is equal to 2. That is rank of this matrix 2. In the second example, row of A, that is rank of matrix A is 3. So now I will do one example. When a given matrix, if they ask find the rank, you have to reduce the matrix into row echelon form, that is upper triangular form, that is elements below the diagonal 0. See, all of you please take this example. This question asked in GATE 2003, 2 marks. Solution. So this is the first non-zero element in the first row. We should make its down element 0. Why I am telling this arrow? Down elements. That is, we always make this matrix into upper triangular form. That is, elements below the diagonal 0. So now you apply row operations. So down elements means down up direction is called vertical, left and right direction is called horizontal. So when I make down element 0, you should apply row operations. So this 6 is located in R2 row, this 2 is located in R3 row, this 4 is already in R1 row. So you make the row operations R2 with R1, similarly R3 with R1. So by making this 6 and 2 0 with the help of 4. So applying R2 changes 2 R2 minus 3 R1. Next R3 changes. Changes means these are the new rows in the next matrix. 2 times R3 minus R1. These two operations on the given matrix, you will get an equivalent matrix. This symbol stands for equivalent. So you will be getting a new matrix. Okay. So that matrix now. So in this R2 changes. Similarly, R3 changes in the next matrix. But R1 remains same. That is 4, 2, 1, 3. Now 2 into 6 minus 3 into 4, 12 minus 12, 0. 2 into 3 minus 3 into 2, 6 minus 6, 0. 2 into 4 minus 3 into 1, simplifies to 5. 2 into 7 minus 3 into 3, that is 14 minus 9, simplifies to 5. Next 2 into 2 minus 4, 0. 2 into 1 minus 2, 0. 2 into 0 minus 1, that is minus 1. 2 into 1 minus 3, that is minus 1. Step 1 over. Now, in the next step, that is in the second row, where is the first non-zero element? 5. So, we should make its down element 0. That is, there is only R3 element down compared to R2 element 5. So, applying the row operation R3 with R2. So, that means R3 now changes to 5 times R3 plus R2. That is 5 into minus 1 plus 5. You will be getting 0. This is equivalent to a new matrix in which R3 only changes. R1, R2 remains same, just like in the first step, above step. 4, 2, 1, 3. 0, 0, 5, 5. 0, 0, 0. 5 into minus 1 plus 5, 0. 5 into minus 1 plus 5, 0. So, this is first non-zero element in the first row, which is a non-zero row. This is the first non-zero element in the second row. So that's why second row is a non-zero row. Third row zeros, all elements zeros. So elements below these three diagonals zeros. So I can say this is row echelon form. Row echelon form. Since it has how many non-zero rows? 2 non-zero rows. Therefore, rank A is equal to 2. So like that, many questions with answers, exercise problems, gate problems available in the refresher course with in detail. A normal student can understand, even if some people cannot understand mathematics. But in our gate for material refresher course, the notes prepared just like reading a newspaper. Everyone can understand with basics, every example they provided. Similarly, test series, gate forum providing so many test series, that is sessional test, topic wise test, full length test, target test, chapter wise test. So that there are 3 types of test series. So if you attempt well, you will get more knowledge. Okay. Similarly, there is live e-gate classes also. So well experienced from NIT, IIT people, they are teaching. So in all the 3 ways, so you will understand, you will get more problem solutions in every subject, not only mathematics. Okay. See, next point is system of linear equations. Yes. Just this topic, matrices chapter, we have studied in 10th class, 11th or 12th class, engineering first year, now again 4th time. Okay. So a set of values of the variables. Variables means other name unknowns. Usually x, y, z or x1, x2, so on, xn. Some people alpha, beta, gamma. Some other people denoted the variables by y1, y2, etc. Which satisfies all the given equations simultaneously. That means at a time, the given x, y, z values, after substituting in the given equations, left hand side and right hand side, they have to get equal value. That is LHS equal to RHS. Then only it is called satisfying simultaneously. So for example, such a values after substituting in the given equation and satisfying are called solution of the equation. So for example, here 2 variables, 2 equations. X plus y is equal to 1, x minus y is equal to 1. So what is linear equation? Every variable having power 1 without products and quotients. Only addition, subtraction. Okay, that is called linear equation in 2 variables or 3 variables or any number of variables. So in 2 variables, x and y, 2 equations. Just by 8th, 9th class, 10th class method, elimination method, cross multiplication method, and advanced level, 11th class, Cramer's rule, matrix inversion method, so many methods are there. But here, if you eliminate, that is adding subtracting method, x is equal to 1, y is equal to 0. If you put x value 1, y value 0, at a time in the 2 equations, you will get right hand side 1, 1. So that's why this is a solution of the equation. So unique solution. While solving these equations, you have only one answer, that is called unique solution, or sometimes no solution. Solution does not exist. For example, here see, x plus y is equal to 1, x plus y is equal to 0. If you put any numbers to these x, y, the both equations cannot satisfy simultaneously. For example, if I put x is equal to 1, y is equal to 0, 1 plus 0 is equal to 1, but 1 plus 0 is it 0? 1 plus 0 not equal to 0. These 2 equations have no solution. When some equations have no solution, such a system of equations are called inconsistent equation. If the given equations having a solution, such a system is called consistent equations. Okay, solution means 2 types. Unique solution, simple meaning single answer, otherwise infinitely many solutions. Now see, general case, a system of m linear equations in n unknowns. Unknowns means variables. That means 2 equations, 3 variables. Such type of problems we cannot solve in our childhood classes, 9th, 10th, 11th, 12th class. More equations, less variables. That is 4 equations, 3 variables. We cannot solve that is by our basic classes, childhood classes, 10th class, 11th class. But any type of equations we can solve by rank method, that is BTech engineering method or gate method. Okay. So is said to be consistent if it has a solution. Otherwise it is said to be. It is means given equation. That means system of linear equations. Inconsistent means solution does not exist. Now, this system of linear equation is of 2 types. One is non-homogeneous equations, other is homogeneous equations. The non-homogeneous equation can be written in the matrix form Ax is equal to B. The homogeneous equations can be put in the matrix form Ax equal to 0. What is O? It is a null matrix, column matrix. Null matrix means all elements zeros. What is this B? Which is a column matrix. non-zero matrix. So whenever the given equations right hand side, one of the right hand side of the equations not equal to 0, that will compare with x equal to b. When all the equations having right side 0, that is comparing with x equal to 0, provided all variables only belongs to left side. Now that variables on the left side that can be put in the matrix form A into x. This x is a column matrix whose elements are variables or unknowns. A is called a coefficient matrix. What is the meaning of coefficient? Just x, y, z, etc. The coefficients of the left hand side equations can be put in the matrix A. Such a matrix A is called coefficient matrix. Now, the combined matrices of A and B. That means putting A and B together in a matrix just by indicating ratio symbol or slash. This is an indication. Side by side matrices. This entire matrix is called augmented matrix. Usually some people denoted by C. Take care. Augmented matrix. So here I provide three equations in three variables x, y, z. 2x plus y minus z is equal to 1. X minus 3y. Here z is absent. That is I can write 0 into z is equal to 2. Minus x plus 3z is equal to 0. Here y is absent. I can write 0 into y. So in the next slide, you will get C. Here only I will write C matrix augmented. So for this, C is equal to A by B is equal to first equation gives first row 2 x coefficient, y coefficient 1, z coefficient minus 1. This is an indication line, vertical line, and the right side first equation 1. Now second equation, second row 1 x coefficient, y coefficient minus 3, z is absent, so I can take 0 and the RHS of the equation constant 2. Next third equation, third row, x coefficient is minus 1, y is absent, y 0, z coefficient is 3 and right side is 0. This is an augmented matrix. How to write from the given equation. Now there is a working procedure to solve these type of equations. There are three types of equations in Ax equal to b or Ax equal to 0. Number of equations is equal to number of variables. Number of equations greater than number of variables. Number of equations less than number of variables. When number of equations less than number of variables, such a system is called undetermined equations. That means in such a case, solution, that means no solution or many solutions exist. When the number of equations more than number of variables, such a system is called overdetermined. In that system, solution may or may not exist. That is, let us see that example. Before that, working procedure, see. Solving Ax is equal to b. There are two steps. First step, reduce the matrix C. What is C? Side by side matrices of A and B. What is A? Coefficient matrix. That is writing all, considering all the coefficients of given variables in a matrix A. What is B? Considering all the right hand side of the given equations in a column matrix B. So this is a special augmented matrix. So this matrix you have to reduce into row echelon form. That means upper triangular form. That means elements below the diagonal 0. Now step 2. So in matrix C, you have either rank A or rank C or both rank A and rank C. When you reduce this matrix C into row echelon form, automatically the matrix A is also reducing into row echelon form. So once it reduces to row echelon form, you will have two ranks. One is A, other is C. So whenever rank A is equal to rank C, then the given equations are called consistent. Consistent means solution exists. Solution exists means two types. When both ranks equal to n, n is called number of variables, number of unknowns, or determinant A not equal to 0. Mod A means determinant A. This det A not equal to 0 is from the procedure 11th standard, Cramer's rule. Then the given equations have unique solution. When both ranks equal but less than n, n is again number of variables, or determinant A is equal to 0, comma adjoint A into B equal to 0. This is from 11th class method. Then the given equations Ax equal to B has infinitely many solutions. When both ranks unequal or det A is equal to 0, comma adjoint A dot B not equal to 0, such a system, that is given equation, inconsistent. That is no solution. Solution does not exist. Please go through this 10 seconds, these 3 points. So I will do 2 to 3 problems. I hope that everyone understanding. in a simple language, that newspaper language or whatever the textbook language I prepared, every normal student can understand. See, let me do this problem. This is GATE 2005 or 2007, 2 marks. Solution. Already the given equations represented in matrix form. So this is A, 3 by 3 matrix. And this is X, column matrix. And this is column matrix B. So the question is, for how many values of alpha the equations already have infinitely many solutions. Infinitely many solutions. Okay. So they are asking how many values of alpha. Take care the language. Now C is equal to augmented matrix A by B is equal to first row 2 1 minus 4 alpha, second equation second row dropping xyz, okay, 4 3 minus 12 5, third row 1 2 minus 8 7. So whenever alpha here located in first row, don't apply directly row operations. You have to bring into the bottom of the matrix. So by applying R1 interchanges R3, this is equivalent to 1, 2, minus 8. This is an indication 7. So first row goes to third row comes down. That is first row comes down, third row goes up, 4, 3, minus 12, 5, 1, 2, minus 8, sorry, this is 2, 1, minus 4, come down, 2, 1, minus 4, alpha. So this is the first non-zero element in the first row. We should make its down element 0. R2 minus 4R1, R3 minus 2R1 equivalent to first row no changes, only R2, R3 changes, 1, 2, minus 8, 7, second row, 4 minus 4 into 1, that is 0, 3 minus 4 into 2, minus 5, minus 12 minus 4 into minus 8, that is plus 32 minus 12, 20, 5 minus 4 into 7, 5 minus 28, minus 23, next 2 minus 2 into 1, 0, 1 minus 2 into 2, minus 3, minus 4 minus 2 into minus 8, that is 16 minus 4, 12, next alpha minus 2 into 7, that is alpha minus 14. Now this is the first non-zero element in the second row. So applying the row operation, making this minus 3 third row element 0 with the help of minus 5 located in R2. So applying 5R3 minus 3R2 equivalent to, so only R3 changes, R1, R2 remains same. First row 1 minus plus 2 minus 8, 7. Second row same, that is 0, minus 5, 20, minus 23. Next 0, 5 into 0, minus 3 into 0. 5 into minus 3 into minus 5, 0. 5 into 12, 60, minus 3 into 20, 60 minus 60, 0. 5 into alpha, 5 alpha, 5 into 14, 70, minus 70, plus 69, minus 1. So first non-zero element in the second row. Here all zeros in the coefficient matrix third row, but we should depend on 5 alpha minus 1. Already given infinitely many solution. So for infinitely, this is given many solutions, we have, what is the formula given? Before that, what is n value? Number of variables, 3, x, y, z. So, what is the formula given? Rank A is equal to rank C. Okay, both should less than n. N means 3. So, this rank A is already 2. Why? This matrix is elements below the diagonal 0. Row, echelon, form. So, in the when you close this last column, the remaining first 3 columns is A matrix, already 2 non-zero rows, that's why rank A 2. So, therefore, rank C is also 2. According to the rank of a matrix row echelon form, so the matrix C has, so here I am writing, C has 2 non-zero, C must has 2 non-zero rows only, matrix C. Okay, that means the last element, last row completely must be 0 in the matrix C. That means 5 alpha minus 1 0 implies alpha is equal to 1 by 5. Therefore, one value, we got one value of alpha. One value of alpha for which equations, EQS, have infinitely solutions. This is the answer. Okay. So C matrix, C must has. What is C means? Augmented matrix must has 2 non-zero rows because of this condition, rank A is equal to rank C. Now, so one asked that Sukunda Das, when you will take calculus part. So after one more session, that is every week, the GATE form, that is the Think Cell group of initiation, they will update in that website. You have weekly classes. Okay. So, and so Arne, one student, how do you convert from GPA, TP, MPA? I am not understanding that GPA, MPA. So that coding language I am not understanding. Okay. So next. One more problem. See, this is also very, very important. Asked in 2007, 2 marks, GATE. For what values of alpha and beta, the following simultaneous equations have unique solution. Okay, very, very important. So 3 equations in 3 variables given. Solution. N is equal to 3, number of variables. Okay, now right side 5 not equal to 0. So this is Ax is equal to B, non-homogeneous equation. So augmented matrix C, that is A by B, side by side matrices, is equal to first equation, coefficients in the first row, 1, 1, 1, this is 5. Second equation, coefficients, that is second row, 1, 3, 3, 9. Third equation comes in third row, coefficients 1, 2, alpha, beta. So this is the first non-zero element in the first row. Reduce this matrix into row echelon form, applying row operations R2 with R1, R3 with R1. So simply instead of writing R2 changes to R2 minus R1, better to write simply like this. R2 minus R1. That means in this row operation, second row will changes in the next step. R3 minus R1. Third row also changes by using R3 minus R1, equivalent to a new matrix you will be obtaining in that R1 same row as first step. That is R1 remains same. 1, 1, 1, 5. Next, R2 minus R1 means 1 minus 1, 0. 3 minus 1, 2. 3 minus 1, 2. 9 minus 5, 4. Next, third row. R3 minus R1. 1 minus 1, 0. 2 minus 1, 1. This is alpha minus 1. And then beta minus 5. So, step 1 over. Now, coming to in the second row. This is the first non-zero element. We should make its down element 0. That is applying R3 operation with R2. Applying a row operation R3 with R2. So 2R3 minus R2. Some people what to do here? Dividing the number 2 in the second row so that you will be getting simpler number 1. Then applying R3 minus R2. But why should we waste time? Because get that question average time is 2.5 to 3 minutes. Some questions 1 mark or 2 marks will take 3 pages or 10 minutes, 15 minutes. Some questions 2 marks will take 3 seconds, 10 seconds also. Average time is 3 minutes. Okay, almost. Now, this is equivalent to 2.5 minutes to 3 minutes. So, in this R3 changes, R1, R2 remains same. 1, 1, 1, 5. 0, 2, 2, 4. 2 into 0 minus 0, 0. 2 into 1 minus 2, 0. 2 into alpha minus 1 minus 2. Simplifies to 2 alpha minus 4. Now, 2 into beta minus 5 minus 4. So, 2 beta minus 14. So, the entire problem depends on the last row. So, please try to understand this last row. Third element is 2 alpha minus 4. This is 2 alpha minus 4. This is 2 beta minus 14. First non-zero element first row. First non-zero element the second row. Now already the question has given unique solution. Okay. So for unique solution, comma, what we have the formula rank A is equal to rank C is equal to number of variables 3. 3 stands for n. So what is the rank of a matrix is equal to 3 according to row echelon form? Matrix A must has 3 non-zero rows. Already first row is non-zero row, second row non-zero row. We don't know alpha value, so I can't say right now this is non-zero row. So that's why to make it non-zero row, this 2 alpha minus 4 must be not equal to 0. That implies 2 alpha minus 4 not equal to 0. That means alpha value not equal to 2. So when this 2 alpha minus is a non-zero element, which is the first non-zero element in third row, that's why this is row echelon form. So observe in every row echelon form, the elements after the first non-zero element, zeros or whatever may be, it is not interested. It doesn't matter. It is immaterial. So always keep on going and remembering for every first non-zero element, your requirement or concentration is left side zeros only, but not right side zero. So this 2 beta minus 14 may be 0 or non-zero. It is any number. So that's why here many people thinks that here beta value not equal to 7. Either beta not equal to 7 or beta is equal to 7. That means beta is any real number. So this matrix is row echelon form. So therefore these are the values. Alpha value not equal to beta is any number. Accordingly, option D is the answer. This is the end of this question. So I hope that everyone following. Let us see. For what value of A, the system of equations, no solution. Three types of problems. Again, three equations, three variables, x1, x2, x3. Okay, solution. Now, n is equal to 3 variables. This is right hand side 4, one of the equation not equal to 0. So, given equations, Ax equal to B, non-homogeneous equations. So, augmented matrix, C is equal to A by B, side by side matrices. First equation, first row, x1 coefficient, x2 coefficient, x3 is absent, so 0. Indication 4. Second equation, second row, 1, 1, 1, 4. Third equation, third row, 1, 2, minus 1, A. So reduce this matrix into row echelon form. This is the first non-zero element in the first row. Applying the row operation, 2R2 minus R1. Next, 2R3 minus R1. So equivalent to, you will be getting another matrix for which R1 remains same, R2, R3 only changes using these operations. So R1 remains same, 2, 3, 0, indication 4. So 2 into 1 minus 2, 0, 2 into 1 minus 3, minus 1, 2 into 1 minus 0, 2, 2 into 4 minus 4, that is 4, 2 into 1 minus 2, 0, 2 into 2 minus 3, 1, 2 into minus 1 minus 0, minus 2, 2 into A minus 4, 2A minus 4. Step 1 over. Now step 2. Second row, this is the first non-zero element. Make its down element 0. So applying the row operation, R3 with R2, that is R3 changes to R3 plus R2 equivalent to first two rows no change, 2, 3, 0, 4, 0, minus 1, 2, 4, 0, 1, sorry, 1 minus 1, 0, 0 plus 0, 0. So this is 0 plus 0, 1 plus minus 1, 0, minus 2 plus 2, 0, 2A minus 4 plus 4, 2A. So first non-zero element in the first row, first non-zero element in the second row. There is no non-zero element in the third row of the matrix A. First three columns is coefficient matrix A. So now this is row echelon form. Now, because already given no solution. What is no solution means? Inconsistent. For no solution, that is inconsistent system, we have, what is the formula? Rank A less than rank C or not equal to rank C. A is a part of the matrix C, but C is not contained in A. So definitely not equal to means 100% satisfies less than only. Rank A less than rank C. Already rank A, the first three columns is already row echelon form. Number of non-zero rows, 2 only. So this matrix rank A is 2. So automatically 2 less than which number? Generally 3, because already the total number of rows in the complete C matrix is 3. So therefore this must be equal to 3. Okay, so which implies rank C equal to 3 according to row echelon form. So implies matrix C, MAT means matrix C, must has 3 non-zero rows. So the last row must be non-zero row means this must be not equal to 0 any element. Therefore A not equal to 0. That means A is any non-zero value. So answer is any non-zero value means real number. Accordingly, option C is the answer. This is real. Any non-zero real value. If A is 0, then what you will be getting? Rank A is equal to rank C is equal to 2. 2 non-zero rows. In that case, the equations have infinitely many solutions. So I'm going to explain that homogeneous system. Now, solving Ax is equal to O. O means null matrix, which is a column matrix. So this Ax equal to 0 is always consistent. So first underline consistent. That means always having a solution. Let us take two equations. X plus y 0. X minus y is equal to 0. So in this example, gives guarantee without solving. X equal to 0, comma, y is equal to 0. See, without solving, all variables equal to 0. That is one of the solution. Sometimes infinitely many non-zero solutions. Okay. So now the procedure. Step 1. Reduce matrix A into row echelon form in this. Here you don't have B matrix. That is right hand side of all the equations 0. So that's why you don't have column matrix B. That's why you don't have augmented matrix C. You have only coefficient matrix A. So first step, reduce this matrix A into row echelon form. Now find either rank of this matrix or determinant of this matrix. When rank A is equal to n or determinant A not equal to 0. Again n is number of variables. Then the given equations Ax equal to 0 has 0 solution only. Automatically 0 solution is also called trivial solution. That means always true. 0 solution. So for this example, see what is A matrix? 1, 1, 1, minus 1. So what is determinant A? Minus 2. AD minus BC, you know that. A, B, C, D 2 by 2 matrix determinant AD minus BC. So this is only 0 solution. X0, Y0. Okay. So when rank A less than n, rank A means it is a number. Rank means number. That number I am taking small r. That value less than number of variables n or determinant A is equal to 0. Such a homogeneous equations, that is Ax equal to 0, has infinitely many non-trivial solution. That is non-trivial means non-zero solutions. Okay. Now also such homogeneous system, when it has infinitely many solutions, some solutions are linearly independent. How many solutions are linearly independent? If they ask, n minus r linearly independent solutions. So where r is rank of A, n is number of unknowns. So what is linearly independent solution? For example, see 1, 2. X1 is equal to X2. 2, 4. Are 2 solutions of 2x minus y is equal to 0. One equation. See, substitute 1, 2 and 2, 4. You will be getting 0 or not. But like that, you will get so many solutions. In all this, if any column means here solution. If any solution is obtained from another solution by a scalar multiple, then such solutions are linearly dependent. Otherwise, such solutions are called linearly independent. Now, this 2, 4 is obtained from 1, 2 by multiplying 2. So these two solutions are linearly dependent. Like that, in all the solutions, only some solutions are independent. One is dependent on other, it is called linearly dependent. One is independent on other, that is called linearly independent solution. So after finding all these solutions and verifying or checking which are linearly independent will take more time. So the authors or scientists invented the formula based problematic approach formula. The number of linearly independent solution is given by the answer n minus r. And you know the last sentence is from BTech first year. Okay, let us have an example. See, the question asked, find the number of linearly independent solutions. All the right side of the equation 0, homogeneous system. So solutions, how many variables? N is equal to 4. The topic is now Ax equal to 0, homogeneous equation. No B matrix, no C matrix. You have directly coefficient matrix. 3 equations, 3 rows, but 4 variables. Less equations, more variables. Definitely infinitely many solutions in Ax equal to 0 chapter. 4, 2, 1, 3. Bracket close. Second equation, second row. 6, 3, 4, 7. Third equation, third row. 2, 1. X3 is absent. 0, 1. Okay. 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. Now reduce this matrix into echelon form according to the explanation in the Ax equal 0 in the previous slide. So first row element R1, make R2 element, R3 element 0 with the help of R1. So applying 2R2 minus 3R1, applying 2R3 minus R1, only R2, R3 changes, R1 remains same, that is 4, 2, 1, 3. Next, 2 into 6 minus 3 into 4, 12 minus 12, 0. 2 into 3 minus 3 into 2, simplifies to 0. 2 into 4 minus 3 into 1, simplifies to 5. 2 into 7 minus 3 into 3, simplifies to 5. Next, 2 into 2 minus 4, simplifies to 0. 2 into 1 minus 2, 0. 2 into 0 minus 1, simplifies to minus 1. 2 into 1 minus 3, simplifies to minus 1. Now, this is the first non-zero element in the second row. Make its down element 0. Applying 5 times R3 plus R2. Only R3 changes. R1, R2 remains same. R3 only changes in the current step, in the next step. So 4, 2, 1, 3. 0, 0, 5, 5. Next, 0. This is 0. 5 into minus 1 plus 5. 0. 5 into minus 1 plus 5. 0. So, below the diagonal element 0. This is row echelon form. So, two non-zero rows. First non-zero element in the first row, first non-zero in the second row. So, therefore, rank A, row A is equal to 2. So, this 2 is now denoted by small r. Hence, number of non-zero rows is the rank of a matrix according to the row echelon form. N minus R, that is 4 minus 2 linearly independent solutions. Okay, I hope that everyone following. Clear explanation, each and every step I have done, I have written. I hope that everyone audible and visible to see. So there are some practice questions. The first question, matrix A, 4 by 4 matrix has rank 4. So before that, just make a 1 minute note point based on rank. So here you can write rank properties. Sometimes questions from conceptual results are note point. First point, rank of any M cross N matrix less than or equal to minimum of rank A, comma, rank B. Rank is always, rank never exceeds number of rows and number of columns. Next, when finding rank of an N cross N square matrix, if you get answer N, implies and implied by such a matrix is non-singular matrix. A is non-singular matrix, MAT mat. Non-singular matrix means determinant A not equal to 0. Next, when rank of N cross N square matrix, if you get less than N, such a matrix is called singular matrix. Singular matrix means determinant A equal to 0. Next, this latest 2020 properties, rank A plus B less than or equal to sum of their ranks. So rank of sum of the matrices is sum of their ranks. And rank of row, product of the matrix. So don't think that this is capital P, row symbol, Greek letter R, you can write R less than smaller symbol, minimum of rank A, comma rank B. So kindly excuse me, here M comma N in the first note point, not rank A comma rank B. This is Kindly excuse me. M is number of rows, N is number of columns. So minimum of M comma N. So please, based on this, I prepared some practice questions. So I will read and answers also. I will read the answers. Just 1 minute. Yes. If you have any doubts, please feel free to ask or post the doubt. Now, the matrix A 4 by 4 matrix 1 0 1 0 0 1 0 1 1 1 0 0 0 0 K has rank 4. Then K is equal to. Okay. For this, any non-zero real number. Answer is option C. So here I am giving the hint. First problem. Determinant A. Not equal to 0. You will be getting K not equal to 0. Because rank A is equal to 4. Now, second question, A is a 4 cross 5 real matrix and Ax is equal to B be a system of 4 linear equations in 5 unknowns, B not equal to 0, that is non-homogeneous system. Then the highest possible rank of A, answer is C. Option is C, second problem. Third problem, let Ax equal to B be a system of M linear equations in unknowns with M less than N. What is the meaning of M less than N? Means number of equations less than number of variables. And B not equal to 0, that is non-homogeneous equation. Then the system has A, B, C, D, 4 options, either 0 or infinitely many solutions. Such a system is called undetermined system. Either no solution or infinitely many solutions. No solution is also called zero solution. So for third question, answer is option B. Next, fourth question. The value of A for which the following set of equations y plus 2z is equal to 0, 2x plus y plus z is equal to 0, ax plus 2y is equal to 0 have a non-trivial solution. Non-trivial solution. That means all the equations having right side 0. So this is Ax equal to 0 system. So non-trivial solution means equate determinant to 0. Determinant A is equal to 0. Then you will be getting answer option B 8. Okay. So this is answer second question and this is answer first question C and this is option B third question and this is 8. So and fifth question answer admits unique solution in option B. So the equations, 3 equations in 2 variables x and y. Ax plus by plus a square is equal to 0. Bx plus ay minus b square 0. X plus y plus a minus b 0. 4 options given. All options related to unique solution. But answer is admits. That means these 3 equations have unique solution. That is single solution on the condition a is equal to minus b not equal to 0. Any doubts? Feel free to ask or clear or post it. So please refer refresher course. Please take that refresher course. 2010 to 2020 all problems solved with detailed explanation and detailed concept notes also available. Okay. Similarly, test series. So there are so many tests. Okay. Whenever you free at any time you can log in and you can do it, the test. There are 3 types of test I already explained: topic wise, chapter wise, full length test, that is syllabus, total syllabus. Okay, so when you're attempting the test, automatically your practice more. That means once you understand the concept or attending the GATE lectures, but practicing the exams, that is attempting the exams, will give more confidence. That is, your confidence level increases. Automatically your knowledge and sharpness also increases. When you are attempting more exams, you will understand, you will get more different types of exams, that is different types of questions and examples with practical approach, that is application oriented problems, shortcut approach, or original conceptual approach, etc. Similarly, live GATE classes are already going. So please subscribe the channel. If you are already not subscribed, please subscribe the channel, everyone. So doubts. Sukanda Das, minimum of m comma n means. For example, see, I'm going back. See, the first property what I told here. This example, 3 rows, 4 matrix. So this is M and this is N. So rank of this matrix less than or equal to minimum, MIN means minimum of 3 comma 4. 3 comma 4 minimum is 3. So rank A less than or equal to 3. But why we got answer? Rank A 2. So 2 is less than 3. That is the meaning of minimum of M comma N. So rank of a matrix never exceeds rows as well as columns. Number of rows as well as number of columns. Next. So Islam, I'm not understand state reason. So what is, which type of reason you want? Next. Shah, sir, in second question, answer should not be 4. Let me check. Yes, that is alpha beta, 2 alpha minus 4. And this is 2 beta, 2 alpha minus 4. And this is 2 beta minus 14. Beta is any real number. Alpha value not equal to 2 only, because 2 alpha minus 4 not equal to 0. That's why alpha not equal to 2. Okay, it is not 4. The next one. Jain, Tanay Jain, what about solutions of practice questions? So just now I explained. Solutions means that based on this session, live session, I have done various examples with the concept also. Based on that, definitely every student can able to do my practice questions. You have all, everyone, every student having great knowledge, mathematics knowledge. Okay, you need not worry about that solutions. You just try, you will get the answers. Anyhow, I provided that keys, that is option A, option C, etc. Next. Nobida, sir, why second answer is 3, not 4? Okay, 3 means option C. Option D is 4. See, if you take alpha 2, so this element 0, that means last row is a 0 row in the first 3 columns A matrix. So rank A is equal to 2. Then rank C is 3. Rank A not equal to rank C, that is no solution when alpha is equal to 2, beta is not equal to 7. Okay, so here I can write for some student, if alpha is equal to 2, comma, beta not equal to 7, then you will be getting rank A not equal to rank C. So this is 2, this is 3, implies no solution. If alpha is equal to 2, beta is equal to 7, implies you will be getting rank A is equal to rank C is equal to 2 less than 3. This 3 stands for N, implies infinite solutions. Infinite solutions. Okay. So almost all doubts cleared. Okay. So thank you everyone. Please subscribe the channel. Bye bye. Good night. We'll meet in the next session. The gate form people will upload that. The next session, topic, timings, everything. See, some of the students asking practice questions. I already explained. Question number 2. Question number 2. Now, A is 4 cross 5 matrix. What is augmented matrix C? Automatically, augmented matrix C has one more additional column. Is 4 cross 6 order. So, just now I told properties of rank. First property, rank of a matrix less than or equal to rows comma columns. So, minimum of 4 comma 5 is 4. And rank of C less than or equal to minimum of rows and columns. So, this is also 4. Next, it is given inconsistent system. See, kindly excuse me, this question, Ax is equal to B be a system of 4 linear equations. All of you please, it's one word missing, kindly excuse me. All of you please write in the second question, Ax is equal to B be a inconsistent system of 4 linear equations in 5 unknowns. So, for inconsistent system, what is the condition? We have rank A less than rank C. Not equal to means less than. So already rank C less than or equal to 4. So rank A less than rank C means rank A less than 4. So less than 4 means you may get 1, 2, 3, highest possible. Highest possible rank of matrix A is 3. So please modify, that means add this inconsistent. In the second question, all of you, A is a 4 cross 5 real matrix and Ax is equal to B be an inconsistent system of 4 equations, 5 unknowns, then the highest possible rank of A. So here we got rank A less than rank C because of inconsistent. So already rank C less than or equal to 4. If we take highest rank C is 4, then we get rank A less than 4. That is why highest possible rank A is 3. Okay. So similarly, you practice other questions. So in this, the hint I am giving for this fourth question, for non-trivial solution, comma, we have determinant procedure equal to 0. So you will be getting, after expanding the determinant of A, you will be getting A is equal to 8. Okay. Now, similarly, in third one, conceptual question, either no solution or infinitely many solutions. Okay. So such a system of equations in third problem is called undetermined. Okay. So I hope that all doubts clear. Thank you. Bye bye.